Hey Nob Hill Nighthawks, here we are with Module 1, Lesson 10. This one is I am successful when I can use place value understanding to round multi-digit numbers using real-world applications. And at the end of Lesson 9, I kind of talked about this a little bit. So today we're going to talk about when is it appropriate to round to certain place values depending on what your problem is. What is it that you're trying to solve? What's your answer that you're trying to get to? So we have our first number and we're going to round it to 3 different place values just to see the difference, kind of like how we ended lesson 9. Okay. So here's, we're going to round to our thousands place first. When we look to the right, we see a 2, which is less than 5. So that tells us we're going to round down. So if we round to the nearest thousands, round to the nearest thousands, we would round this to either 935,000 or 936,000, but because it's a 2, we're rounding down. So here's our nearest thousands place. So this is our thousands. And then we could do 10,000s. Okay, so if I look to the right, I see a 5. That tells me I'm going to round up because our rounding rules are if it's 5 or more, we round up to the next number. So because we have a 3 here, that means this, instead of our low point would be 930,000, our high point's 940. So that's what we're going to round up to is 940,000. Here's our 10,000s. And then our last one, we're going to round this to the nearest 100,000, which is a 9. So I can round this down to 900,000, or I can round this up to 1 million. Because there's a 3 to the right, that means we're going to round down to 900,000. Okay. So when we look at those 3 different numbers, we can see that when I rounded to my thousands place, it got me the closest number to my actual number. So depending on what we're working with, is going to determine which place value we want to round to. If I were to talk about how many boxes I need, if I needed this many boxes, this rounding to my thousands place wouldn't be reasonable because I wouldn't have enough. So you have to think about what is your problem, right? What are you trying to figure out? If I was trying to order this many boxes, it would make more sense to round to my 10,000 because then I have more and I have enough, more than what my actual number is trying to get at. Okay, so we're going to use this information to talk about, for example, in the year 2012, there were 935,292 visitors to the White House. And we're going to assume that each of those people, this is our number, each of those people got a map of the White House. And so for 2013, they want to figure out how many maps are they going to need to order. So if this was their previous year, would they want to order less than what they already had? No, probably not, because if we had this many the previous year, we probably want to assume that we're going to get more, right? If we round to our 10,000s, that's going to give us more, so we'll have extras. So, but that would cover, maybe we're assuming that it's going to get a little bit more and more each year. This would be more reasonable, right? And especially if we look at our 100,000s, because we rounded down, then we would have much less than the previous year. Okay, so we're going to use another story problem, and we're going to use our reasoning to decide which place value we want to round to. And I always recommend that it's good to round to 3 different place values before you decide and then compare, okay? All right, so our word problem is there are 2,837 students that attend the Lincoln Elementary School. So it's 2,837. If we had to order chairs for the school, what place value would we want to round to make sure that we have enough chairs for these 2,837 students? So let's round it to 3 different place values before we determine our answer. Okay, so let's start with our thousands place. I look to the right, I see an 8 because of our rounding rule. That means we're going to go up to the next 1,000. So 2, 3. So if we round to our nearest 1,000, we would round to 3,000. Okay, let's go to our next place value which is hundreds. I have an 8 in my hundreds place. So my low point would be 800. High point would be 900. When I look to the right, I see a 3. 3 is less than 5. So we would plot it below our midpoint, which means we're going to round down. So 2,800 would be our nearest 100. Okay. And then let's do one more. If we round to our nearest tens, we have a 3 in our tens. So our low point would be 30. High point would be 40. When we look to the right, we see a 7, which is larger than 5. So if I were to plot this number on a number line, I'd be plotting it above my midpoint. So 2,837, we round into our nearest 10, would be 2,840. Okay, so now let's think about our question. They have 2,837 students. They're wanting to order chairs for all of the students. Would we round to the nearest 1,000 at 3,000? Will we round to the nearest 100 or tens? Because if we round to the nearest 1,000, we're going to have quite a few extra. Think about school buildings. Are they going to need an extra 100 and plus chairs? Probably not, right? If we round to our nearest 100, we're not going to have enough. We need 2,837. When we round into our nearest 100, that was 2,080 or 2,800, excuse me. So that wouldn't cover the students. If we round to our nearest tens, we have 2,840, which is really close to the amount we need with just a couple extra. So rounding to your nearest tens would be the most reasonable way to round for this problem because of our situation. Okay, so it all is going to depend on what the question is asking. What is it that they're trying to do, trying to get, trying to order? So you just have to use your reasoning, connecting that to real life, thinking, well, that would be probably too many. That wouldn't be enough. This would be just right. Okay, let's try one more. Okay, so we're going to do one more word problem together. So this one says, Empire Elementary School needs to purchase water bottles for field day. There are 2,142 students. Principal Vader rounded to the nearest 100 to estimate how many water bottles to order. Will there be enough water bottles for everyone? Explain. So they rounded to the nearest 100. So let's see what they got. Here's our hundreds place. When I look to the right, I see a 4. So if I have 100 in my hundreds place, 100 would be my low point, 200 would be my high point. Because 4 is less than 5, that means we're rounding down. So I would round this to 2,100 if I was rounding to my nearest 100. Now think about that for a second. Are we going to have enough water bottles? If there's 2,142 students, he rounded to the nearest hundreds place, which got him 2,100. He's not going to have enough, right? So in this situation, it would almost make more sense because look at all of our numbers. What do you notice about each place value? If I were to round any of those place values, I'm going to be rounding down, which means I'm going to have less than what I need. So when you have something like this, it might make more sense to use your reasoning and say, well, if I need 2,142 water bottles, I should probably order 2,200, right? To make sure you have enough, or 2,150. But because of our rounding rules, anytime we round all these numbers that are less than 5, no matter which place value we round to, we're going to get less than the amount that we need. Okay? So I'm going to be posting another word problem for you guys to do on your Edpuzzle, and then we'll be doing this in small groups as well, and interventions if you're with my group, using that 4-square model. And you guys have chances to ask questions. As always, send me messages if you need any help, or if something was confusing on the video, please let me know and I'll clear it up. All right, you guys, have a great day. If you notice my homeroom kiddos, I have our artwork that we did today. Happy October, and I hope you guys have a fabulous day. We'll see you soon. Bye-bye.